Alright guys, so we're ready to start chapter 5. So now we're going to start talking about a little bit about probability. So chapters 5 and 6 both deal with probability. So chapter 5, and this will be the last chapter before the midterm, is titled Modeling Variation with Probability. So then some chapter 5 topics that we're going to look at is we want to be able to use empirical and theoretical probability models. An empirical probability can also be called experimental probability, right? And we're going to talk about both of those in this section. And then also in chapter 5, we want to be able to apply basic probability rules. So that way we can make some probability calculations. So section 5.1 is titled What is Randomness, right? So that's the focus for this section is, what truly is randomness. So one thing we want to be able to do is use a random number table or technology to simulate randomness, and then also be able to distinguish between empirical and theoretical probabilities. So first, let's recap what is randomness, right? So randomness is when we have no predictable pattern, right? And also, it was identified in the section, it had an example where they asked someone to, write down, what was it, like 10 coin flips randomly, and then they use a computer to generate, and you can tell the difference, right? Because people aren't good at identifying truly random samples or random experiments, right? So it's really hard to identify. It's also really hard to generate on your own, right? So typically, if you want to come up with some type of random sample that you want generated, you would use a computer, or you could also use like a random number table to do this. Right. So here's an example, just trying to simulate randomness using a random number table. So the random number table is in the back of your book. I believe it's Appendix A. So here it's saying use row 30 from that random number table to simulate 10 coin tosses. So we're going to let odd numbers be H and even numbers be D, right? So what is the longest streak of heads or tails in your data? So if I go to the next page, right, this is an example of using the random number table. So here's just this snippet of that random number table. We want to use line 30, right? So every odd number, we said, gets heads, and even number gets tails, right? So you can see they transposed every odd number to heads, even number to tails, and wrote it here, right? So we're looking for what's the longest streak. The longest streak I put in red font, and that's where we get 4 heads in a row, right? That's the longest streak there, right? So now let's talk about probability. So probability is used to measure how often random events occur. Also, I don't think it was in this section, I didn't write it down, but it's also important to understand that probability is in between 0 and 1, right? 0% and 100%. Right, so don't forget that. So now it says when tossing a coin, the probability of a head is 1/2 or 50%, right? So we can show probability as a fraction, a decimal, or a percent, right? This means that the coin will land on heads about 50% of the time. So we do have 2 types of probability, as I mentioned before. We have theoretical and empirical. And you can also note, like if you read in other texts, a lot of mathematicians will also write experimental probability instead of empirical, right? Either way. All right. So theoretical probabilities, in a sense, are when you conduct an experiment an infinite number of times, right? So for example, it's easy to think about like flipping a coin. So if you were able to flip a coin an infinite number of times, then you would arrive that 50% of your flips were heads and 50% were tails, right? So that's how we come up with this theoretical probability. So they're long run relative frequencies, right? And remember, relative frequencies we talk about with histograms. So to get a relative frequency for heads, for example, you would take the number of heads that you got and divide it by the total number of flips, right? So there's just an example which I already said, right? So if we were to flip a coin infinite many times, exactly 50% of the flips would be heads, right? So this is the idea with theoretical probability. And now coming back to this, so it is really hard to, to imagine flipping a coin infinite many times, right? So we do have a number of ways to come up with the theoretical probabilities, which we'll talk about a little bit in this chapter. So empirical probabilities or experimental probabilities they're still relative frequencies, but these are based on an experiment or an observation of a real life process, right? So empirical probabilities aren't always going to be the same, where theoretical probabilities are always the same. Like, so if two people calculate theoretical probability of an event, as long as they both agree on the same theory, they're going to get the same number, right? But with empirical probabilities, if I repeat it and someone else repeats it, those aren't going to be the same, right? They could be the same, but unlikely to be the same. Right? So here's just an example. So if I just toss a coin 10 times and get 4 heads, then I got a 40% probability, right? So that's an empirical probability, experimental. You're carrying out some experiment and then just using that as your results, right? So here's comparing theoretical versus empirical probabilities. So I was saying before, theoretical probabilities are always the same value. So example, theoretical probability of getting a heads when tossing a coin is always 0.5 or 50%, right? That's a agreed upon number, right? Tails and heads are both equally likely. And then the next bullet point is that empirical probabilities change with every experiment, right? And I just want to point out that two empirical probabilities could be the same, but the point is they typically change with every experiment, right? So here's an example. If I toss a coin 10 times to get 7 heads, the empirical probability of heads is 0.7 or 70%. Where if I toss a coin 10 times again, I might get 3 heads. So the empirical probability of getting heads is 0.3 or 30%, right? 3 out of 10. So you might wonder, why do we need 2 probability models, right? So we do need 2. One bullet point is that theoretical probabilities may be difficult to compute. So in that situation, we can use empirical probabilities to help us estimate the theoretical probability, right? So like I can, conduct the experiment like 10 times, 100 times, 500 times, and see if this starts to approach one set number, right? Is one way to do that. And also, another bullet point, another fact is that we may not trust the theoretical probability model, right? So maybe the model is based on faulty assumptions and we don't trust it. So we would like to get empirical probabilities to help us verify or refute a theoretical value, right? Can help us make sense if, what's wrong with our theory. So simulations. So experiments, we often use simulations to produce empirical probabilities, right? So instead of actually flipping a coin 100 times, we can use a simulation, right? And I'm going to show you one of those in a moment. So here I'm just pointing out we use the random number table to simulate tossing a coin 10 times, right? This is a type of simulation, right? So you can use like a random number table like that, or you can use other methodologies, right? All right, so I do want to point out that you can make like a random number table or do simulations like in R or in your graphing calculator. I don't want to in this video I don't want to go into how to do that with R. And I wanted to show you in the calculator how you can do a like a model like a coin toss. But the problem I ran into is, I mean, I don't know if you guys know, but the calculator that I bring up on screen for you is an emulator. It's not actually a graphing calculator, so I'm unable to download anything onto my emulator, and I can't pull that up. But a lot of you probably have a um, probability simulation program pre-installed on your calculators. Like if you hit program, you might see something to that effect, like coin toss, probability simulation, so forth. If you do, you could play around with that if you're interested. Um, but but again, I can't show it to you at least through this emulator, right? So if I think it's real important, I'll find a way to show you how to do it, right? All right. So one thing I would like to do is I did post this website um, as a resource for this section on Canvas, and this is a pretty cool website. So this is a way to generate coin tosses. So for example, if I don't want to toss 100 coins, I can come in here and use this random simulation to model that for me, right? And so I can put 100 and click toss them, right? So now it's tossing the coins. And one thing that I really like about this simulation is you can display results as a list, like what we have now. I can also click on table, and it gives me a summary. And then I can also do ratio, right? So these would be the relative frequencies, right? So that's just really nice to see, right? And then so I could do click 100 again, and now it's going to keep my previous 100 and add another 100 in, right? To get the number of tosses. If you don't want to add in your previous results, and what you can do is hit clear results, and then you start over, right? So this is a pretty neat simulator that you can play around with, right? And we're gonna come back to this later on because we're gonna talk about a theory that I like to model with this type of simulation called the law of large numbers, right? So we're gonna come back and talk about that. All right. Well, that's really all for this section. So, complete the homework and let me know if you have any questions.